So here's a quick simple example showing how to apply mesh analysis. So in this case, they're asking us to solve for the current IL, which you can see runs down this way through the resistor RL. So let's apply mesh analysis and see how we would approach this. So we want to define, we have two loops, so we'll define two mesh currents. So this will be I1, and then we'll define another one going clockwise in this loop is I2. So let's look at loop 1 first, which we're associating with the red. So again, we're summing up the voltages around the loop. So in this case, we see that I1 goes through this device here. And so that's going to be I1 R1, and we'll just write it out, put in values in just a minute. And then we also see that it goes through our load resistor here in green, and so we'll write that then as plus I1, I1 RL. And so that's all the things that I1 goes through. We see that we should notice that I2 also goes through this resistor, and it goes in the opposite direction of our I1, so therefore it works against it. So that being the case, we would need to write that then as minus I2. Oh, we'll do it in blue since that's what we designated that. It'll be minus I2 RL. And so that takes account everything in our loop except for the voltage source right here. Voltage source right here. And we see that that voltage source, because of the plus sign, is working in the direction of our voltages. So therefore, we're going to say that's plus 42. And so now we've accounted for all the voltages in our loop. If we were to add those up, they should equal to 0. And now let's move over to our next loop, which is I2. So again, in this case, we see we have the green resistor, and so that's going to be I2 times RL. And then we also see that we have this R2 here, and so that's going to be plus I2 R2. And finally, we see, as we did before in the RL circuit, that I1 is working against us, so then that'll be minus I1 RL. And then finally, we have this voltage source, and because of the plus sign again, it's also working in direction of our I2, so therefore it would be positive. And so we'll say plus 21 volts, and again, that should all equal to 0. So now we have two equations, and we can plug in values that we know and come up with the resultant equations, so, and reduce things down. So this one, if we were to do that, we would have R1, which is 3, RL, which is 6, so that's going to be 9I1. And then we'll also have the 6 ohms, so that's going to be minus 6I2. That's going to be equal to minus 42. And then for this one, we would have minus I1 RL, so that's going to be minus 6I1. And then we have have a 12 and a 6, so it's 18. So it's going to be plus 18 I2. And so that's going to be equal to minus 21. And so now we have our two equations and our two unknowns, and we can apply whichever way you would like to. You can use matrix analysis or whatever, but that's linear algebra problem for the most part. So when we do solve for those, we get that I1 is equal to 7 amps and I2 is equal to 3.5 amps. But what they asked us for was IL. So we can see here, IL is a combination of the two. So it's going to be I1 minus I2. So in this case, that's going to be 7 minus 3.5, which that'll be 3.5 amps. So the current flowing through the resistor RL, which is the current IL, would be 3.5 amps.